The end quote, Mothership Theory end quote, unfurls a truly extraordinary vision, not just a conventional comet, but potentially a colossal 5-kilometer carrier, a veritable leviathan of the cosmos accompanied by an unfathomable retinue of perhaps 1 trillion discrete objects. As astronomers continue to scrutinize 3I/Atlas, the familiar narrative of a simple, icy wanderer increasingly unravels, giving way to something far more enigmatic, even profound. Imagine, if you will, a vast, shimmering halo of countless macroscopic entities, not haphazardly strewn, but maintaining an astonishingly stable, coherent formation throughout its perilous journey across the solar system and Apos' immense canvas. These are not the ephemeral ice particles of a typical comet and Apos' tail, destined to sublimate and disperse under the sun and Apos' fiery gaze. Instead, these enigmatic companions steadfastly defy such terrestrial expectations, remaining intact even as they reflect the overwhelming majority of the light we observe, all while constituting only a minuscule fraction of Atlas and Apos' total mass. What precisely are these silent, resilient escorts, and how do they so stubbornly resist the very forces that tear ordinary comets apart? Their very existence challenges our deepest assumptions about cosmic wanderers. The nucleus itself, a formidable chunk of cosmic matter, is estimated to stretch approximately 5 kilometers across, a mini-world unto itself. It carries an almost incomprehensible minimum mass of tens of billions of tons, yet hurtles through the vacuum at an astonishing 60 kilometers per second. This ISN and Apos' merely fast. This is a velocity that utterly dwarfs the capabilities of any spacecraft humanity has ever conceived or launched. Atlas effectively shrinks the cosmic calendar, allowing it to bridge distances in mere months that would consume years for our most advanced interplanetary probes. But perhaps even more astonishing than its sheer scale and speed is its trajectory. It is anything but random. Picture a master navigator guiding a colossal vessel. Atlas doesn't and Apos' just stumble into our solar system. Instead, it enters with remarkable precision, aligning itself eerily with the ecliptic, the very plane where our planets orbit. It then proceeds to thread a needle through the inner solar system, sweeping past multiple terrestrial worlds. And at its closest approach to the Sun, its perihelion, it performs a subtle, yet undeniable, act of course correction, a measurable non-gravitational acceleration that precisely retargets it, with chilling accuracy, towards the hallowed bounds of Jupiter's Hill radius. Is this the capricious dance of a natural body, or the calculated maneuver of something far more deliberate? This target, Jupiter and Apos' Hill radius, is no arbitrary destination. It and Apos' a cosmic sweet spot, a gravitationally balanced region universally recognized as the optimal staging ground for deploying satellites with the absolute minimum expenditure of energy. And Atlas, with astonishing foresight, is predicted to arrive there on March 16, 2026, not merely close, but within the infinitesimal margins of measurement error of this perfectly ideal distance. Can such pinpoint accuracy be merely the haphazard outcome of gravitational billiards? This level of precision bears the unmistakable hallmark of sophisticated navigation and meticulous mission planning, a far cry from the undirected chaos of natural drift. Concurrently, the enveloping swarm of 1 trillion objects continues to mystify. It exhibits none of the expected characteristics of scattered debris. Instead, it behaves with an almost uncanny discipline, much like a carefully protected payload, steadfastly remaining intact and coherent across the wildly fluctuating thermal environments encountered during its epic journey. When we coalesce these disparate observations, the astounding size of the nucleus, its breathtaking velocity, the undeniable course correction at perihelion, the perplexing integrity of its surrounding and Apos' cargo and Apos', and the uncanny geometry of its destination, an overarching narrative begins to emerge. These elements Don and Apos' just align. They interlock, forming a coherent framework that speaks not of natural happenstance, but of purpose. We are left contemplating nothing less than a colossal carrier vehicle, an interstellar transport ship, ferrying a massive, enigmatic payload towards a strategically invaluable location within our own solar system. And what a location it is! Jupiter, with its immense gravitational dominance and its iconic retinue of moons, Europa, Ganymede, and Callisto, represents a veritable treasure trove of environments, each brimming with exceptional scientific interest, from subsurface oceans teeming with potential life to complex geological histories. While the precise nature of this payload, whether it comprises sophisticated probes, advanced sensors, or even sophisticated organic delivery systems, remains shrouded in mystery, the collective behavior observed is strikingly, almost disturbingly, consistent with an intentional design, a deliberate mission, rather than the boundless coincidences of the cosmos. The coming months promise to usher in the ultimate litmus test for this audacious hypothesis. Forthcoming spectroscopy data, offering tantalizing clues about the composition of Atlas and its retinue, coupled with the climactic rendezvous at Jupiter, will collectively provide the critical, defining evidence. Should the objects within that enigmatic swarm indeed separate from the colossal carrier, not merely dispersing but establishing stable, enduring trajectories within the complex gravitational embrace of the Jovian system, a controlled deployment, in essence, then this, end quote, mothership framework, end quote, would transcend the realm of intriguing theory. It would cross an irreversible threshold, shifting from audacious speculation to a staggering, undeniable confirmation, forever reshaping our understanding of what might traverse the boundless ocean of space. The universe, it seems, may be far more engineered than we ever dared to imagine.